A few things that we need along with that. Definition of a polynomial, we have touched on this before, but we're going to look at it again because it is important. So a polynomial is just when we have a lot of terms added together. A's are just numbers out in front. Typically, if it's written in decreasing power, the power of x gets smaller each time. What is the degree of our polynomial? What does degree refer to? Mm-hmm. In this scenario here, if I write out that polynomial, my highest exponent would be n. What are coefficients? The numbers in front of the variables, which in my scenario, that's all my a values. What's the constant? That's it. That's my a sub 0. What is my leading coefficient? We know coefficients are the numbers in front of variables. So, right, it's the one that is with the highest power. So it's the coefficient of the term with the highest exponent. If it's written in decreasing order, that's the first one. It doesn't necessarily have to be. That's just our standard form. So it'd be that a sub n. And the leading term is the entire term with the highest exponent. So that term is the number with the variable. When we graph our polynomials, the graph is always going to be a nice, smooth, continuous curve. So there are no breaks in the graph. There are no corners or anything like that. It's just a nice, smooth, continuous curve. Any transformation rules that you've learned in the past will also be true. Nothing changes there. One other thing to note is in a polynomial, all exponents are whole numbers. What are whole numbers?
Exponents greater than 1 without being fractions?
Yeah, it could technically be 0 as well. So 0, 1, 2, 3, 4. So nice exponents there. You won't have any fractions or negatives or decimals in your exponents. All right. Let's look at some problems then. I want to decide if these things are polynomials. If they are, I want to give the degree. If not, we're going to tell why not. So, is the first one a polynomial? Yes. Okay, Okay, what's my degree? 4. Is B? No. Why?
Does it have any exponents or variable?
It has an exponent. A square root is the same as what power?
Excellent.
1/2. Is 1/2 a whole number? No. So you have a fraction for your exponent, so it's not a polynomial. Is C a polynomial? So the top is, the bottom is,
Not been divided.
but not when they're divided. It's a division of two polynomials, but the whole thing is not. So, no, your reason, you could say variable in the denominator. Okay, it'd be okay to divide by 5, have 5 on the bottom, but having a variable on the bottom is like having a -1 for your exponent. Polynomials can't have negative exponents. Alright. Is D a polynomial? Technically it doesn't break any of the rules, but the degree is the tricky thing. Isn't 0 the same thing as 0x, which would be degree 1? Isn't that the same as 0x squared, which would be degree 2, or 0x to the third, which would be degree 3? So in this case, we say there is no degree. If it's just a 0, you can't identify what that exponent is. It could be anything. So 0 is like the special case. It's the only one where we can't give a degree. All right, E. Is that one okay? Yeah. Oops. Said yes and I wrote no. All right, the degree. 8. Is 8 the same thing as 8x? No. What would that power have to be so the x would disappear?
0.
So this one is degree 0. Degree is kind of like how many variables are there. If it's just an 8, there is no variable. And f. If I multiplied this one out, would it be a polynomial? Yeah, we multiply it all out. Okay, my degree is the highest power when it's all multiplied out. So I could sit and multiply this whole thing, but I really don't even have to. I just have to think, if I multiply it out, what would my highest power of x be?
X to the 4th.
I have 3 right here, but you would square this first, right? So you would end up with an x cubed times an x squared, which would give you x to the 5th. So the degree is 5. Do you guys understand how I got the degree there? So when it's multiplied, we have to think about, or it's written in that factor form, we have to think about when we multiply it out, what would our power of x be? Okay. I want you guys to take a minute, you can use a graphing calculator if you'd like. I want you to draw a rough sketch of what these 4 things look like. You can use your calculator if you want. Give me a. All right. So x cubed, we should know that one. We've seen it before. That's just our chair, right? What's x to the 5th? Yeah, it's just a skinnier looking chair. It has their same original points, but then after that, like first this was 2.8, this one's 2.32, so you're just getting a skinnier chair. Okay. We know what x squared looks like. We've seen it before. That's our parabola. What's x to the 4th? Okay. So x squared and x to the 4th have the same general shape. X to the third and x to the fifth have the same general shape. If I said x to the seventh, what do you think it would look like? The chair. If I said x to the sixth, what do you think it would look like? Parabola. So what we're seeing, if you just have x to a power, it's going to look like x squared if that power is even, and it's going to look like x to the third as that if that power is odd. As that exponent gets larger, the graph narrows. It just gets skinnier and skinnier. All right, so this is really important. When we go to graph polynomials, we can look at it and have an idea of what our shape will look like. This is called end behavior. So as it turns out with polynomials, it's really just the leading term that impacts what the ends are doing. So I look at that highest power of x, regardless of what else is in that polynomial. That highest power of x is dictating what the polynomial itself looks like, what the ends are doing. So the end behavior is determined completely by that leading term. And we have two cases to worry about, if it has even or odd degrees. So if we have even degree, okay, if our coefficient has even degree and a positive coefficient, it's like a parabola. Both ends are pointing up. I am real precise about this. We're just going to draw arrows. If you happen to look in your book, it sometimes says like, as x approaches negative infinity, f of x approaches infinity, and as x approaches infinity, f of x approaches infinity. I just feel like that's unnecessarily wordy. We don't need that. So just know if you look in the book, if you're going to see something like that, we're just going to draw arrows. Okay, that's more practical. We're trying to get a graph overall. I'm just looking at what direction the arrows point. What would happen if I put a negative coefficient? If I said negative x squared, both ends point down. Okay, so anything with an even power, the ends are doing the same thing. Positive coefficients, both ends point up. Negative coefficients, both ends point down. If our leading term has an odd degree, then it looks like that chair. So my ends, the left side is pointing down and the right side is pointing up. What happens if I have a negative coefficient? It switches. This end will go up and that end will go down. Any questions? So we're going to practice that. I want to look at some polynomials, and we are going to decide their end behavior. And when I ask for end behavior, all I'm wanting is for you to draw me arrows. What are the ends doing? So to do that, you first have to decide what's your leading coefficient. And be careful, it's not always the first one. It is if it's written in standard form. But you're just looking for the term with the highest power. So in this one, that would be 4x cubed. So x cubed tells me what? It's an odd degree, so it looks like a chair. A positive 4, so it doesn't flip. So my end behavior would be down up. All right. Second one. If I said negative x to the 6th, x to the 6th, so my degree is 6, that's even, so it will look like a, it starts out like a parabola. What will the negative do? Flip it upside down, so both ends are pointing down. Okay, the third one. This is in factored form. All I need is the leading coefficient. I just have to think, if I multiply this out, what would my highest power of x be? So if I'm just worried about the highest powers of x, I have a 3, I have an x, this parenthesis would give me an x squared. So I would have a 3x cubed in there. So x cubed tells me it is a odd power, so it looks like a chair. Positive 3 in front, so it doesn't flip, so my ends are down and up. This one, all I have to think about is if I multiply it out. So I have 1/2, I have an x squared. X squared to the third, if you have a power to a power, what do you do with those? Yeah, you multiply it with that 3 that's on the outside. That's x to the 4. And then once I have all my x's written, I add those exponents. So that would give me x to the 12. So even powers look like a parabola. The 1/2 doesn't cause it to flip because it's positive. So both ends are pointing up. Any questions, sir? Yes.
How did you get x to the 12?
I added these exponents. So 2 plus 6 plus 4. So it's all together, how many x's do we have? Other questions? Okay. So let's look at this one. I want to find a polynomial that meets this requirement. We've done some of these before. We were doing them in the last section. Degree of 3 just means it has to be x to the third, or 3 parentheses. If negative 3 is a 0, what do I have to have in my polynomial? X plus 3. If 2 is my 0, I need? If 5 is my 0. Okay. Is that degree 3? Yep. Did I give any other requirements? No, so that's all I need there. Thank you. All right, B. Degree of 4. If 0 is a 0, what do we have to have? Just an x. If 4 is a 0. If 12 is a 0. Okay, what's the degree of that?
4.
I said it had to be 4, didn't I? Is it degree 4 right now? No. Did I tell you which of them had a multiplicity? No, so technically I could put it on any of them. To make degree 4, I just have to make one of those squared. Now, the square could be on any of them, because I didn't give the multiplicities. If I had given it, then it would matter which one. Alright, C. If negative 1 is my 0, we would have, if 1 is my 0, that's minus 1. And if 2 is my 0, it's minus 2. That's my degree 3. The last thing, a y-intercept of 1. That means when x is 0, y is 1. What do I have to find? I need, not necessarily my x, but remember we had some before where there was a number in front. So since I gave you a point, we need to figure out what that number is. Alright, so if my x is 0, this whole thing has to equal 1. So that number has to be 1/2. polynomial is 1/2 x plus 1, x minus 1, x minus 2. I'd like to do just a few more slides if I could. Any questions about these? The next thing on here is just a terminology. Zeros are numbers that make my polynomial equal 0, right? There are other terms that you could use for those. So you might say it's a solution to the equation when it equals 0. It's an x-intercept, or x minus that number is a factor. So the big thing you need to know is something with a factor has x in it, a 0 is a number. So a 0 is always just a number. A factor is when you have x minus the number. And we've kind of seen that on the problems we were doing in the previous section. I'd ask you to list the zeros and also the factored form. And the factored form is when we put the x's with it. So, can you tell me all the zeros and multiplicities of this? It's already factored, so we just have to set each parenthesis to 0. So what makes x minus 2 equal 0? 2. What about x plus 3? And since it was squared, what about x minus 1/2? And since it was to the 4th, multiplicity 4. Alright, you guys try B. List the zeros and their multiplicities. So, a plain x is just 0. So x plus 1 equals 0, you get -1. What about 3x minus 2? Multiplicity 3. And x minus 5? Okay. So any problems finding the zeros if it's in factored form? The final things I want to touch on today. 2 very brief things and then we're stopping. The shape of a graph. The multiplicity changes your shape. It's telling you how many times something is a 0. Okay, we know a 0 is in other words for an x-intercept. So if something's an x-intercept, we know it crosses the graph there. If that power is odd, the graph will go through the 0. Okay, whether that exponent is 1, 3, 5, 7, 9, it's just going to go right through that 0. But when your multiplicity is even, think about x squared. If I just gave you x squared, you have your 0 is 0 with the multiplicity of 2, right? What does the graph of x squared do at 0? It touches it and bounces back up. Anytime your multiplicity is even, the graph will bounce at the 0. So odd multiplicities go through, even multiplicities bounce. And the final thing that I just want to mention today, underneath it, it has turning points. When I'm talking about turning points, that's just when your graph changes direction. And it's related to the degree. So if your degree is n, you have at most n minus 1 turning points, and that works in reverse. So for instance, if I give you this graph, how many turning points? How many times does this graph change direction? Twice. So this is 2 turning points. So my degree has to be at least what number? Except does my end behavior match for an x squared? Now my end behavior, the ends are going opposite directions, so I know it's odd. Your degree has to be one more than your number of turning points. So that has to be at least degree. It could be more, but it has to be at least. So if I gave you a graph with 7 turning points, what would your degree have to be? 8. The degree is higher. Now, if I said the degree was 12, how many turning points could you have? 11. Okay, so that's a relationship there. That is my stopping point for today. There is a handout posted